Okay, good morning for day two, seventh graders. I hope you're ready to jump in with some more math. I hope it's not too overwhelming to try and do all this online. But we are now on 10.2, which is page 435. Hard to believe we've already made that far in the year, but we have. So if you want to follow along with me in your book, that would be a great idea. So if you want to turn in your book to page 435, if you need to pause me in order to get there, go ahead and pause me, get your pen, pencil, paper, whatever you need, go ahead and get it out. So our first definition here is what we call permutation. Now you may say, I have never heard that word, and that is okay, because this is a weird word that we really only use for math. So sorry about that, but yes, this is not a normal one that we think of. But the way you're going to see this one used a little bit more, but the one we're going to first focus on is what's called a factorial. And the way that's written is that you have any number and then you have an exclamation point. So you could have 6 exclamation point, 7 exclamation point, 13 exclamation point. You could have anything like that. So what that means, as you will see here, is if you need to finish writing that down, go ahead. I'm going to go on to my next screen. So if we have 6 exclamation point, what that equals is 6, okay, that makes sense, times 5, times 4, times 3, times 2, times 1. Now, the great part about that is you all have calculators, and you're at home, so you literally just type that in your calculator. 6 times 5 times 4 times 3 times 2, and you don't have to multiply by 1. You can if you want, and you get the total of 720. So 6 exclamation point equals 720. Okay, if you need to go ahead and write that down, go ahead and do so. If you need to pause me, go ahead and pause me. But I'm going to do another one. So here's what it would look like if we did 9 factorial. That would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Go ahead and type that all in your calculator. You do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you get a really big number. So if you're still typing that in your calculator, don't look at the screen yet, but it's 362,880 is our factorial of 9. Okay, that's easy to do. That's the first part of our lesson. You guys will have no problem with that because you have a calculator and you're smart. So I have great faith in you. Now, this is where we get a little harder and we use our idea of permutation we talked about at the beginning. Didn't really explain it because I needed you to see the formula. So, the permutation formula looks like this. It's a little n, a big P, that stands for permutation, and a little r. Now, what do these different things stand for? Well, R is going to be, this is for the time or the specific amount, okay? So it's a specific number. The N stands for the total, okay, for the total. So this is very abstract. I know it's really hard to kind of think about that. Like, what does this mean? So I'm going to give you an example. So for example, if the problem said something like this: find possible arrangements for 7 objects that can be that are all arranged. Okay, what that means is that you have 7 objects and you have all, which is also 7, are arranged. So in this case, the total is 7, so we put a 7 where the n is. We keep the p, that one never changes. And then how many? How many specific amount? Also 7. Now, what does this equal? That equals 7 factorial. Hey, we know how to do that, right? So if you see something very, very important for you to pay very close attention right now. If you see something where this and this are equal, okay, then you write it like that, okay? So that's just a formula you can write down. So if you see, if any time those are the same, okay, so let me erase over here so I can give you another example. So if these are the same, if they're ever the same, so if they didn't even tell you what it was, but they said 3p3, you know that that's going to equal 3 factorial, which would be 3 times 2 times 1, which is 6. Okay, does everybody see that? So if they're the same, then you just use the factorial. That's the easy part of our formula. Now is for the hard part. So hopefully you understood that. Here's where it gets a little more complicated. So if they give us something, our formula here, right, we're going to go back to it, times r. Now, the way we solve this, if they're different, is we have to do this. N factorial, right, so the factor of this one, divided by n minus r factorial. Okay, that's the way we write this notation. So, for example, if they gave us something that said out of 5 objects, we are only going to use the first 3. Okay, what that means is we have 5 is n, right? And replace the n, you see that, and 3 replace the r. So we have 5 factorial divided by, in parentheses, 5 minus 3 factorial. Now that rewrites as 5 exclamation point over 2 exclamation point. So what that means is then we just subtract, right? The factorials are going to stay the same, so we just subtract 5 minus 2, and we get 3. So our answer is going to be 3 factorial. So what that, or sorry, don't listen to me. Not going to be 3 factorial. We don't subtract these. So we have this right here, 5 to the factorial up top, and we have 2 to the factorial on the bottom. So the way that we would write this is we're actually going to write this out. If you want to do this, 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Now, when we divide, we cancel out what is the same. So the 1s are the same, cancel them out. The 2s are the same, we cancel them out. Which leaves us with 5 times 4 times 3. You do that on your calculator and you get mighty 60. Now, I know that's a little weird to follow, so I'm going to do it again. I'm going to do it a bunch of times, okay, so you can get used to seeing it. So really, let's do another one the same way. So we have, let's say they give us 8p6. Now I have 8 on the top times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of that divided by what is 8 minus 6? That's 2 factorial. And 2 factorial is equal to 2 times 1. So what does it cancel out? Just the 2 and the 1, just the 2 and the 1. So I'm left with all of that multiplied together. And when I type that in my calculator and multiply that, I get 20,160. Okay, so if you're tracking, 20,160. Now, those of you that are maybe more perceptive here, you can see what this means. So go ahead and write that down if you need to, but I'm gonna clear it and I'm gonna do it again. Okay, now look at this right here. Let's do this again. 8 and 6. What this right here means is the number of times. So what I could do is start with this number. That's my 8. I start with 8. That's 1. And I could just go 6 times. Times 7, that's 2. Times 6 is 3. 5 is 4. 4 is 3. All right, look. 1, 2, 3, 4, 5, and 6. And that is the same answer as doing it the other way. So if that way that I just did it made more sense to you, you can just do it like that. We take the first number and we do it times the number that is on the right side. Okay, so let me do one more example here for you. So let's say that they say 14 objects go into 10 compartments. Okay, now you may say, which is R, which is N? Well, here's the trick. N is always bigger. So N in this case has to be 14, P, and R must be 10. So the way we're going to solve this is we're going to have 14 up at the top. So we're going to have 14 factorial divided by 14 minus 10 equals 4 factorial. So what that means is that we're going to have 14 here 10 times. Okay? So 10 slots. So what that means is we're going to have 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 times, come on, no, times 5. There's our 10th one. Now, did you notice that it stopped right in front of 4? So that's how I knew if I didn't want to count, I could have just stopped at the 1 and said, okay, it's going to go to 5, but it's not going to touch 4. And when you multiply all of those numbers together, you get a very big number that I'm going to do on my calculator, which may break my calculator, maybe not. It is a huge number, so if you actually did try and solve this, I'm going to write it up top for you. So you type that in your calculator, you get 3, 6, 3, 2, terrible 6, 3, 2, 4, 2, 8, 8, 0, 0. Look at that. That is 3,632,428,800. That would be the permutation of getting 14 objects into 10 compartments. Okay, if you have questions about that, go ahead and watch that video again. Pause it if you need to. Here is the homework for this lesson. So this is 10.2. This is page 437. So we're going to do 1 through 12 all. Then we're going to do 15 through 18 all. Then 21 through 23 all. And lastly, 27 through 33 all. Sorry, through 32 all. I want to save you that one problem. Okay, through 32 all. So there's our homework. Go ahead and upload that to me, send that to me, and we'll be good to go. So if you have questions, go ahead, feel free to reach out to me. Good luck on doing this. Please let me know if you have any issues. Mr. H is over and out.